Okay, next up, we're looking for the Lewis structure for the following. And so we have BF4 minus is our first one. As usual, we're going to count the valence electrons. We will have 3 from the boron, plus 4 by 7 from the fluorines, plus 1 because of charge. Let's go ahead and label these. So boron, 4 minus charge. And that's just going to give us 28 plus 4. So 32 electrons to take care of. Let's start with our skeleton structure. We know boron is going to be the central atom because 8 minus 3 is equal to 5, and that is going to be greater than 8 minus 7, which is equal to 1. And so boron can make the most bonds in this scenario. And so let's start with our structure and single bonds between each and fill in our octets for each of the fluorines. And see if all of the electrons make sense for our valence. And so we have 6 by 4 plus 8, which is just going to give us 24 plus 8, and that will give us our 32 electrons. So all of our valence electrons make sense. Let's double check on our formal charges. We expect a net formal charge of -1. For each of the fluorines, we're going to have 7 minus 6 minus 2 over 2. So formal charges, this is for fluorine, and that's going to just be equal to 7 minus 7, which is 0. For the boron, we're going to have 3 minus 0 minus 8 over 2. That's going to give us 3 minus 4, which is -1. So we're going to have a negative charge on the boron. Does that make sense? It gives a net formal charge of -1, so yes it does, meaning that this is going to be our final structure. Valence electrons are taken care of, formal charge is taken care of. On to the next one. We have Cl2O. Let's count our valence electrons. We are going to have 2 by 7 because of the chlorine, plus 6. And that's just going to give us 14 plus 6, which is 20 electrons to take care of. We can label these as Cl2O. And so let's start with our structure like this. So Cl, oxygen clearly deserves to be in the middle because 8 minus 6 is 2, and 8 minus 7 is equal to 1, and 2 is greater than 1. So oxygen can make the most bonds in this case. Let's start with a single bond between each and filling in the octets. And see if that matches our valence electrons. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So our valence electrons are all taken care of. Let's double check on our formal charge. On the oxygen, we're going to have 6 minus 4 minus 4 over 2. That's just 6 minus 6, giving us 0. On the chlorine, we're going to have 7 minus 6 minus 2 over 2 for both of them, which is 7 minus 7, giving us 0. This makes sense. We expected a net formal charge of 0, which we've gotten, and the valence electrons are all taken care of. So this is our final structure. On to the next question. We have NH2OH. Again, count the valence electrons first. We're going to have 5 plus 3 by 1 plus 6. This is going to give us 8 plus 6, which is just 14 electrons. We can label these. This is N, H3O. Let's figure out what our central atom is going to be. For nitrogen, it can make 8 minus 5, so 3 bonds. Oxygen, it can make 8 minus 6, so 2. Hydrogen, it can make 8 minus 1, so 7. But typically, hydrogen can't be the central atom because it can only make 1 bond, actually. So nitrogen is clearly going to be our central. We can place those around it. And that's the OH. Let's add 1 bond in between all of them. Sorry, we have 3 hydrogens, not 4. Let me just restart that so you can see how it got there. We said nitrogen is clearly the middle. Let's put 2 hydrogens around it. and the oxygen, we know hydrogen can make optimally 3 bonds. So we have 3 things around it already. So let's put the H on the other side of the oxygen. Start by adding 1 bond in between each and filling in the octets. And then let's see if we have enough electrons. So we have 2, 4, 6, 8, 10, 12, 14. So yes, all of these are taken care of. Let's double check on our formal charge. For the nitrogen, we're going to have 5 minus 2 minus 3 over 2. Sorry, 6 over 2. Because each of these count as 2 electrons in each bonding pair. That's going to give us 5 minus 5, which is 0. Oxygen, we are going to have 6 minus 4 minus 4 over 2. 6 minus 6, which is 0. Hydrogen, we are going to have 1 minus 0 minus 2 over 2 for each of them. That's simply 1 minus 1, which is 0. Formal charges make sense. You expected a net formal charge of 0. Valence electrons are all taken care of, meaning that this is our final Lewis structure. And then lastly, we have CH2 CCl2. So let's just rewrite that in our C2, H2, Cl2. Let's count our valence electrons. We're going to have 2 by 4 plus 2 by 1 plus 2 by 7. That's going to give us 8 plus 2 plus 14. So that is 24 electrons to take care of. We can label these. This is the C2, H2, Cl2. And so clearly here we're going to have C. Let's put the H on one of them and the Cl on the other. Let's start with a single bond between all of them. And filling in our valence electrons, our octets. See if that adds up to 24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So clearly we have too many electrons here. Now we need to figure out the best lone pair that we can move into a bonding pair. If we move the Cl's ones, so let's say we decide to make a double bond here, that means Cl is going to have a formal charge of something other than 0, and the carbon is going to be fine. But it's going to mess up our formal charge more than if we instead decided to make this double bond here, because carbon can still make one more bond. And so let's leave it like that and see. So now we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now all of our electrons are taken care of and everybody's octets are filled. Let's double check on our formal charge. For the hydrogen, they're going to have 1 minus 0 minus 2 over 2 for each of them. And that's going to give us 1 minus 1, which is 0. For the carbons, we're going to have 4 minus 0 minus 8 over 2. That's 4 minus 4, which is going to give us 0. And lastly, for chlorine, we are going to have 7 minus 6 minus 2 over 2 for each of them. So 7 minus 7, and that is going to give us 0, 2. And so these formal charges make sense. We expected a net formal charge of 0, which is what we have. And so this is going to be our final structure. If we'd like to be a little more correct, we can write it in a way where its geometry would be reflected. And so we can write it out like that. And that is going to be your final answer with the octet and the chlorines.